the question which we discussed today, this is about how to prepare and publish a paper in pure mathematics. On one side, this may look like something quite routine and boring, but in my opinion, this is very important. I think about this a lot in my own practice, in my work with students, and I will share with you my opinion, some advices, tips. Some of them, as to me, are obvious. Some of them may be a reason for discussion. And if you don't agree, this is completely okay. I will be glad if we will discuss them. What I will also want to say, certainly the main point in mathematical research is to get some new, original, I would say, brilliant result. No doubts, this is most important part. But some people, especially young researchers, they think that if the theorem is proved, this is the end of the story. In my opinion, definitely not. Because there is a task to write good text, to publish it in some reasonable journal. And this also requires some time, some expertise, and some effort from your side. And please don't estimate this as something more or less automatic or easy. This is hard work. Also, in my opinion, this is our duty to produce good papers, something like pieces of art. Say this is not something like an engineering technical report or just instruction, because in engineering, people produce some equipment, devices, and they should be beautiful. And these instructions, these extra texts, they looks like something secondary. But in pure mathematics, we produce only texts, nothing else. So no chance our text should be beautiful. And we should invest a lot of time into this business. So now short outline of my today talks. I am going firstly to speak about preparation to writing. I presume that result is already obtained. I don't discuss how to prove theorems. I think that you already have result and you are ready to start writing. So firstly, how to preparing to write, then some tips from my side for writing. Our next step is how to choose a suitable journal and how to submit the written paper to the journal. In fact, the order of these items in this list is also subject of some discussion, but we will do it during the talk, what to do first and what to do next. Then there is a very important part, very important point, how to communicate with the editor and with reviewers. This is a source of quite usual mistakes, and I would like to stress on this. But let us start from the beginning. I would like to propose you to go to the poll and to face multiple choices. What difficulties do you face when you start writing a mathematical article? So let us look to opinions of all our participants. I expect that all participants of our today's seminar already have some experience with mathematical papers. Maybe some people will say that everything is difficult. This is also true, but here we should somehow make priorities in this list. Now, the leading point is to write the introduction. There is a question in the chat what to do if somebody hates this procedure as a whole. Okay, maybe. In any case, if you want to write mathematical article, you will face with this difficulty. So
about 80% of the participants have voted, so I think we can close the poll. Yeah.
Thank you very much for participating in this poll. So as I also expected, the introduction is the #1 most difficult point. Also, quite a popular answer is to start writing. Yes, I understand this, to force myself to sit and to write. To fix notation and to follow it throughout the text. Yes, some of my colleagues say that this is killing them because we will discuss this a little bit later. Also to decide that the paper is ready and to stop it. Maybe this is personal, for me it's not a problem, but here 13% of participants marked this point as something quite difficult. One person said that to add examples and applications, this is a difficult point. Certainly it depends on the subject. So, okay, I think that we already analyzed the result of this poll. So I propose to go to the next slide. And now we start from first steps. So I think that you already have at least a rough opinion about what you are going to write. You look at theorem you already have in mind, or you write it with some colleagues, with some co-authors, and you say, okay, we are ready. We decided that we should prepare this paper. Firstly, I think it's reasonable to decide what type of the paper are you going to write. Should it be a note or an article or an all article, a long article, or even a survey? And this is very important to decide at the beginning because it influences on the writing process. If you decided that your result is quite short, proof is not so long, and explanation, motivation, and so on will not take a lot of space in your paper, then it will be a note, and then this is easier from the point of view of writing. If it is a standard article, I don't know, maybe notes is something like 5, 8 pages, more than 10 pages up to 25. This is maybe usual article. Long article, maybe this is from 30 to, I don't know, to 80 to 100. There are such articles, and there are journals which accept long articles. But you may also decide that this your results is a good reason to write a survey on the subject. New results are very welcome to survey. It's nice that you prove something also, but also you survey the corresponding area. And maybe this is a different story. Today we will not discuss how to write a survey, but I just want to stress, to turn your opinion, to turn your attention that your result may be a good reason to write a survey as well. And also, one more comment on this subject. It's good to fix the circle of authors, who will be the author of this paper, at the very beginning. And if possible, also to fix the title. Then I would like just to say that when we prepare article, it's very good to understand from the beginning who are the authors and what is the title. Title you can change during preparation, but say who participate in the article, who are co-authors, this is a source of possible conflicts. And for predicting this, I strongly recommend to decide it at the beginning. When I was young, I didn't understand why some people don't want to discuss some results which are under preparation. In my opinion, this was something very strange. Okay, so no secrets. I don't want to. Somebody will be stolen, nothing like this. But some people don't discuss. And later I understand the reasons for this. Because say together with my students, we are the two possible authors. We discuss somebody with a third colleagues. And this third colleague give us some ideas, some advices, some suggestions. At some point, it's difficult to decide whether we should invite him or her to be the co-author of the paper, or we should just thank at the acknowledgement, or what to do. So at least please think about such situations. When you discuss something, when you invite or not invite somebody, this is a source of possible conflicts. But okay, let me presume that we know who will be the co-authors of our paper, and we go to the next step. Next step, this is, sorry, let's return just on the second step, read related articles. In my opinion, this is also very important. Even if you work in this field rather long time, even if you think that you are an expert in this area, it's always useful to Google, say, I prove some theorems about locally important derivations of graded algebras. I think I know everything about this, but it's a good reason to Google such a word combination, locally important derivations of graded algebras. And sometimes I found paper which I didn't know before. So, and if I decided to write a paper, even not a note, but say a long paper, it's very important to mention all related results in the introduction, in the text. So please invest some time in this. Google is the is only one possible variant, but you can also use some database of American Mathematical Society, MathSciNet, of European Mathematical Society, Central Blood, and Russian resource, MathNet, which I also strongly recommend. In my opinion, this is quite good. What can you do? Say, you know which paper do you going to cite. I know, say, some brilliant result of Jean-Pierre Serre. I go to his paper. And then I look to, in all this database, this is possible, I look which paper cited this paper by Jean-Pierre Serre. And I go to this paper and to this paper and go through some graph and look, are this result related to what I am going to prove in my paper, or this is something completely else. And by this chains of citation, I quite often found something new. Okay, so this also takes some time. Definitely, some people don't like it, but in fact, this is this is really mathematical work. You read some results, some proofs, some ideas, and this is not so boring as somebody can think. So I just would like to stress your attention to this database. If you work in a team, decide who does what and start writing. Okay, as we already discussed, this is important to decide who are the authors. But now, what to do? How to distribute duties if you are not alone? In fact, quite a big difference between pure mathematics and other area is that in pure mathematics, people often work alone. But now there is a tendency that the number of authors increases and increases. And in my opinion, this is good, up to reasonable limit, but nevertheless, because this is some fun to work with other people. Not so many people maybe will read your paper, so you have some at least obvious candidate to read, to think, to discuss. Also, you will produce more. If you have not one hand, but many heads, then you will produce more results. This is quite good reason to work together. But this is also a source of conflict because people have different standards. Some people think that it's very important to write perfect text and to invest a lot of time. Some co-authors might decide that this is a strange idea. So theorem approved, and this is not our business. Are they understandable or not? Do we have good notation or not? So I propose to stop. We can submit now in such a rough form. No continuation. And also people have different style of writing. Say we can decide that I am responsible for section number 2, you are responsible for section number 3, and so on. And when we take all sections together, it's clear that text is somehow disconnected because different style. And when I also is a reviewer of some papers, and it's clear that some papers are written in this way, one section by one person, second section by another person. In my opinion, this is bad. So say journals, they like that there is some corresponding author who communicates with the editor and so on. And also I would recommend to have some writing authors who compile the final text and even write the final text. Say when I work with some colleagues, usually it's clear who is this person, who is a writing author. And we send some pieces of text, some pieces of proofs, some ideas for introduction to this central author, and he discusses with us, say, okay, I agree, or I will include like this, or I will correct something, or I'm against. I think this is a strange idea to mention this in the introduction. And text is produced by one person. I have a paper in Duke Mathematical Journal where we have 5 authors. And some people ask us how it's possible in mathematics to work 5 people. Exactly because we have this star graph structure. There is one author in the center of this graph, and all others send him some pieces, some ideas, and so on. In my opinion, this is a good idea. And also, this person, he has or she has a terrible life, but nevertheless, also he or she is responsible for correcting remarks of the reviewers, editor, and so on. But certainly all people understand that he is doing hard work and we help him as much as possible. when I send him some piece which is unreadable or which need a lot of work to produce some text from this, certainly this is not good from my side. I should send to this central author the text which is perfect from my opinion, and then he correct it as he likes. Okay, but this is just my, again, personal proposition. Certainly, if you can do it in other way, no problem. This is about preparation. I don't know what you prefer. Me personally, I would start from the table of contents. I would divide what I am going to write into sections and subsections. Certainly, I will change it many times during the preparation of the text. But at least from the beginning, I would like to have some skeleton. Some tips concerning this. I would recommend to make sections and subsections of the compatible size, of compatible volume. Say, if your section number 3 is 15 pages and section number 4 is 1 page, then something is wrong. Please think more, reorganize somehow. And also section and subsection, this is also some point where you should think about the material. What are big pieces, main points, what should be sections? And subsections, this is only when you need to subdivide a section in some smaller pieces, then also this is reasonable to do. The idea of this division is to help the reader to understand what you are going to prove, to say, because you should understand very obvious thing. Mathematical texts are usually difficult for understanding. And all what we discussed today, this is some attempts from our side to explain to the possible reader what we are going to prove and to say. And good structure in the paper, good table of content will help a lot at this point. Also, maybe one more observation. Say, you know that there is some statistic of American mathematical societies that the major parts of mistakes in mathematical paper correspond to the word obviously. So if you say obviously in some proofs, then two variants. Either this is really obvious, but then you should have inside, you don't need to write it, but if you are asked, you should explain why it is obvious and so on. Or this is some point which is difficult for you to explain, and you want somehow to skip it, to omit this place. Or, okay, obvious, please, dear reader, check it. This is your business. One can easily check also another variant for obvious. This is not a good idea. So please think about correct, complete arguments. And even I would recommend to write them down. And then when you read it, and when you're honest with yourself that this is really obvious and this is clear, then you can omit it. This was just some analogy with the table of contents. Which one? When you think about obvious points, this is some sign that you should think more. Also, if your table of contents is strange, disbalance of volumes, you cannot understand how to subdivide it. Say one section has 5 subsections and other section have no subsections. This is a point to think more. There are some situations when this is okay, but in most cases, you will change the structure and you will come to the better result. Okay, point number 2, about notation and terminology. This is really terrible. Especially when you write long texts, especially survey, especially books. This is extremely very, very difficult. Because first, naive advice. Decide what do you denote by which letters. Say, vectors, elements of a set, you denote by small Latin letters. Some sets, you denote by big Latin letters. Some, I don't know, something, what do you need? Some elements from some other type of sets, you use small Greek letters, and so on. But very often you come to interior contradiction. Example, you have some set, and it's very natural to denote the number of elements in this set by small Latin letter n. At the same time, you work with some vector spaces. And you use notation for dimension of this vector space. And it's also very usual in many areas of mathematics to denote the dimension of your vector space by small letter n. So you obtain two completely different notions denoted by the same small letter n. This is catastrophe. You should change it. When you realize it at the end, you should maybe change a lot. But please do it because notation are very important for understanding. So please change your notation if you see some interior contradiction. I know very peaceful people who become very angry after 2, 3, 4 such interior contradiction. But no chance, you should, because use, I don't know, Gothic, some specific letter. This is our good point that in LaTeX system, we have many possibilities, many options to change letters, and we can use many different type of notation. And also please think about logic. It's strange when you denote elements of a set by capital letter and self itself by small letters. This is also some non-logical notation, okay? Also about terminology. If you produce some new terms, say in your work, you want to introduce some completely new notion, or you have some complicated construction, say a set which satisfies this and this and this condition and blah, blah, blah. And you repeat it many times. It's good to introduce just one verb for this. So also introduce some terminology. All this is also a difficult point. And here you should think not twice, but many times. Because people who don't care about this and who produce important paper, important result, they make a lot of troubles for their successor, for people who will work in this field later. Say people with Olympiad background who participate in mathematical Olympiad in school time, they like very much to say, this set is good, this set is bad. This is good, this is bad. And there are examples even in fundamental mathematics of this type, and say in the area where I work about algebraic transformation group and quotient, there is a notion of good quotient. This is completely well-defined notion, good quotient. And this is commonly used. It was introduced by some very high-level mathematicians, Sheshadri. But people, when they mention in their talk such a notion before white mathematical audience, they apologize for this. So this looks strange. Good quotients, there are some bad quotients. Or please think many times. It's nice when terminology refer to some existent, I don't know, animal or something in biology or something in, I don't know, chemistry. This is certainly good, but also don't try to be too much emotional in your terminology choice. Use some standard complex. Be ready to justify why do you use this terminology. Because if you pretend that you prove something important and this will be used many times by many people, you should explain why do you use such strange term like, I don't know, germ, or many examples of C-Evit algebras. In fact, very nice term, C-Evit algebras. It was introduced some years ago, and now this is quite common. This is example of very good terminology. This was not used before. This is no intersection with already existing terminology. It has some reason. Why do we use such a term? Because these algebras, they correspond to some subalgebra in the algebra of matrices, and this is really look like C-Evit. And people like it, people use it. There is a difficulty when there is a conflict of terminology. Say there are two papers which introduce similar terminology, but this terminology is different. What to do, what to follow? If this paper appear simultaneously, okay, this is our life, nothing to do. But if, say, the second paper was later, and this second guy was lazy to read already existing terminology, then this is bad. I would recommend to study and don't introduce new terminology if already there is one. Okay, this was about point 2, and now we should go to the point 3. After introduction, as we saw in our poll, this is a very difficult point, and I recommend you to write introduction at the end. But before introduction, after introduction, there should be some background. You should fix some notation, not to introduce new notations, but to follow standard notation, just to mention, to list them, and also recall and shortly explain some basic facts which are common in this area of study, and also define just some notions. This is also quite difficult, but people, this is not such a, something is difficult to study, you should have some talent. Say introduction, maybe it requires talent, but this background, this is quite standard. So after some thinking, you can do it a standard way. There are two extremes, either not to give background at all. This is very bad idea, because even professionals will not understand you. And in, I don't know, in mathematics, we work for future, and say in 50 years, nobody will understand you because terminology may change. So it's very important to recall what you call by what, or just to give a list of notations. Yes, this is possible, but this is also quite boring. It's better to say some words, some explanations, connecting phrases, some comments. And another extreme is to write too much, to give all examples, illustrating all definitions, to prove some basic lemmas which are already in all textbooks. This is bad because, firstly, you decided that what you write is not textbook, this is not survey, this is note or short article, so this is not a textbook. Please don't do it. Your possible reader is a mathematician, but this mathematician, not a student of first year, bachelor student, this is professional mathematician, but maybe from other area of mathematics. So you don't teach him, you just recall him or her, what do you mean by what? So it should be done briefly and carefully. Also, maybe you return to this part when you write the body part of your text, because you see that you will use it, and this notion you will not use. So you decide what to include at the beginning and what not. When this part is ready and when your paper is ready, I strongly recommend you to check that everything what you recall and this background part is really used. If it's not used, please cross out it. You don't need it. Also, say, when I was in Tübingen in Germany, in Karl Eberhard University, it was a lecture by some German professors who is a specialist in history of mathematics. And they say that not even in, I don't know, old Greek times, but even at the beginning of 20th century, it was a paper by Hilbert. And it was about some algebraic objects. And they say that now people cannot understand this, because in this paper by Hilbert, there are some reference, not to the list of reference, but reference inside of the text to some lemmas. They use some names, I don't know, Greek lemmas. And in Hilbert's time, it was common. All people around him knew what is Greek lemma. But now, in 100 years, people don't use such terms. They don't know what is a Greek lemma and why this lemma implies this statement. And now nobody can read this paper and make the proof precise. So even what is completely common for you, it's good briefly to remember, to recall the statement and to use it now without any problem. Okay, so now let us go to the next slide. Okay, now we come to the presentation of main results. And this part, I hope, is completely obvious for professional, experienced mathematician, but I would like to say some words to students. Please think what are theorems, what are propositions, and what lemmas are. These are completely different things. Maybe at next point, because maybe it was not written. So what lemmas are? They are technical statements which are needed for your proof, which are needed inside of this text. Here it's written, supporting statements, technical. You will refer to lemmas. It's very strange to have lemma which you don't refer inside the text, because lemma, this is something technical, something secondary, but they have no values in its own. Oppositely, theorems are core results. These are main results of your paper. Say, if I don't want to read your paper in details and just want briefly to look what is it about, I read the formulation of theorems. So what do you prove? And propositions, they are something intermediate. They should have value in their own. Say, if your statement is this terrible expression is equal to this terrible expression, and it's just a part of some proof, then this is a typical lemma. This is not proposition. But if you expect that some people in some other paper will refer exactly to this point, to this statement, it's reasonable to call it proposition. Okay? So this is your choice. You decide what is valuable, what is not. But think about this. It's a bad idea to have too many theorems. I remember once we got quite negative report on one of our paper, and it's what's written that these guys, we are, the authors, have too many theorems and no deep results at all. I remember this. It was a hot night after reading such a report, but I at least partially agree with the author of this report that yes, we had, I don't know, 10 theorems in one paper. It was a bad idea. We should have 1, 2, 3, I don't know, 3. Okay, 5, but no more theorems by which are our results. We can also mention many theorems which we use, which were approved by other people, but main result should be not too numerous. In my opinion, this is a bad sign. Okay, next point. Also, in our poll, not so many people, in fact, just one person said that it's difficult to provide examples, corollaries, and applications. Again, it depends on the subject. In some areas of mathematics, applications are visible and it's easy to illustrate by examples. But I would say that this is very important. And when the main results are proved, this is not the end of the story. You should look for examples and applications. Some example may be a toy example, elementary example. It's good to put them even in introduction to show the reader what's going on, what happens in this text. By applications, we may mean different things. This will be really applications which are applied to some, I don't know, other area of science or other area of mathematics, and which may simplify some computations. This may be easier new proofs of already known results. And this is also a good point. Journals, they don't like to publish new proofs of already known results. It happens sometimes, but quite rarely. And this is somehow against the policy of leading journals. They want to they want to publish original results. But if your results are original, but you want to illustrate them by new proofs of already known results, this is a good point. Examples, what do I mean by this? Say we prove something difficult about higher dimensional situation. What can we draw? We can draw two-dimensional case. Sometimes we can draw three-dimensional case. Some very experienced author can even draw something in dimension 4, but it requires some talent. Please do it, because it really helps to the reader to solve our main problem, to make understanding of the proof better. Would you use pictures? It depends on your quality in typing. If you are experienced person in LaTeX, if you can do pictures in LaTeX or export it from some other system, please do it. Certainly when you will communicate with journals, this should be a separate file. For some people, such technical difficulties, for example, for me, they are crucial, but if I have a co-author who can do it easily and include some illustration, okay, certainly not too many, because mathematical paper, this is not a place where you should put many, many pictures, but some pictures are welcome. Please, when you put some list of examples, think, say you want to illustrate some effect. Please do not include several examples which illustrate the same effect. It's sufficient to use just one example. Check that your examples, they illustrate different things. They show that, say, your theorem has some requirement. And if you omit this condition, then the theorem is wrong, first example. If you omit the second condition, your theorem is wrong, second example, and so on. Or when you apply your theorem, you may face this difficulty and this difficulty. Two difficulties, two examples, something like this. Corollaries, the same story. Think in the hierarchy of corollaries. You may start with some obvious, clear corollaries, and then go to some more advanced statement. If it requires some long proof, then you may call it not corollary, but again, some proposition theorem, and so on. Okay, this next point. About LaTeX. This is very important because I'm sure that among participants of our today's seminars, there are people who use LaTeX professionally, and there are some people who just start to study this. And this is a hard work. Firstly, I think that there is no doubt that we should use TeX, at least TeX. There are several versions of. I don't insist on LaTeX. There is IMS TeX and other version, but let me call for today LaTeX as a synonym of TeX. We should use this system because this is standard for mathematical paper, at least in pure mathematics, as far as I understand. To use, I don't know, Word or some other system, it will be strange. Okay, if we agree that we should use LaTeX, then there is different type of understanding. How should we use LaTeX? Some people think that we use LaTeX only to type formulas, nothing else. No, this is definitely wrong. Let me give one example. You want to use theorem. Some people make some empty space, say small skip or some other comment from LaTeX, then put theorem, make it in bold format, it should be black, then some small skip after the formulation of the theorem, and so on. So this is a manual work. You do it by hand. This is a very bad idea, and this is always visible. Even if you try many times to find this distance between what is before your theorem and what is after your theorem, it always will be clear that this is done in a non-standard way. I strongly recommend to use standard LaTeX tools, something like begin theorem, end theorem. Then the system itself will produce correct empty spaces before, after the theorem. Sometimes they use some specific font, something special for theorem, something special for corollaries, remark, and so on. And when you see that it's done in a standard way, the paper looks really professional. Certainly, LaTeX is as difficult as you like. You may, I don't know, spend all your life studying new and new features, new and new possibilities, and maybe this is too much. But some time to study LaTeX is completely needed. You should know how to make specific mathematical symbols, what people use usually, and so on. So before typing even your first mathematical paper, you should, I don't know, speak with somebody, somebody should check that you already is well qualified to use, I will not say all, but main options which LaTeX proposed to us. Okay. So dear colleagues, I speak with the screen maybe so quickly, and now we come to the most difficult point, to the introduction. So maybe I will stop for a moment, and maybe there are some comments, remarks, questions, suggestions. Please maybe type it to chat or say something.
So there are two questions there.
I see only one. Is it useful to practice to use some sort of graph of notions to avoid conflicting notation. What do you mean to use a graph of notions? If you do it by yourself, say on some paper, then certainly this is your choice, up to you. If you have such a big pool of notation and they need to be organized as some graph, okay. To include some graph of notation to the text, no, maybe this is too much. If it's not a book, I would not recommend it. The question about this is what I say, the two notation n is a notation for a number of elements and n is a notation for a dimension of some spaces, right? Tatiana, this is your question, right? What to do with this? Oh, this is a difficult question. This really depends on you. No easy solution, because it's very common to use n in the first sense and n in the second sense. You can say that, okay, I don't use the same n at the same page, so I can. I will not agree. Even if they are not used at the same page, it's better to change notation. This is a personal choice. You should decide what is more important for you. Say, if your paper is mostly about number of elements, and you write it in, I don't know, for some combinatorics, the people who works with the set and who usually use n for denoting the number of elements in a set. Then, okay, you say, I use it for these people, and for dimension, you use other letter, say D, because D is also good for dimension. If this is about linear algebra, then you can vice versa. Insist on the term dimension and use n here, and to use some other letter for number of elements. So this is some art, no easy decision. But please think about this and look for this decision. Don't ignore this difficulty. Also, very difficult point, and this is extremely funny, and I met it just some days ago in some paper. When this conflict of notation, it becomes very visible when you need to write n with index n. This is terrible. So something is wrong and you should change something. Okay, maybe some more questions or comments are very welcome. Yes, Maxim informed that there are fonts, he lists concrete fonts, which help to use more specific names. This is a good idea. You mean, but Maxim, let us discuss what do we mean. Say, we have such a conflict. One letter n denotes number of elements and dimension. And we use some meticulous specific font for another n. Say I use by usual n number of elements and by this strange n dimension. Again, it depends on the text, but sometimes it looks not so good. Because people who use n for dimension, they use usual n. And this your substitute, well, people will smile, but I'm not sure that this is a good smile.
Well, I think actually when you discuss some general objects, say in discrete optimization, it's quite common that they have, say in traveling salesman problem, they have set of points, which is denoted as X calligraphic, and they also have like set or, but well, okay, suppose you have a transportation problem, and transportation problem usually have a number of sources and a number of targets or clients, right? And often it is the case that the number of clients and the number of warehouses is denoted as, say, calligraphic M and calligraphic N. The sizes of these sets denoted as just Latin letters. And maybe there are also some small letters for numbers which are related to the sets.
Okay, so I see. Okay, if there are no more comments, questions, then I continue. There is a comment by Maria Yutkevich. When your result is an extension of some existing theorem, should we follow the notation? Yes, this is a very good question, because this is some source of, again, of this contradiction. You cite different theorems, and in one theorem, n is a number of elements, in another theorem, n is a dimension. And you should follow the notation of previous authors, and then you have this conflict, no decision. Okay, then you should change notation at least in one formulation. No, it's not necessary to follow the notation given in this former publications. It's good to preserve notation, but if it leads to the conflict, then you definitely should change. And notation in all theorem you cited should correspond to notations in your paper. This is, in my opinion, this is absolutely necessary, and no discussion on this. Okay, let us go further. Now we come to introduction. We agreed that this is the most difficult part, and I strongly recommend write it at the end, when all other sections are already written. Me personally, when I prepare the paper, I make a section introduction. This is empty section. And when I write other sections, I put some ideas, some phrases disconnected to this part introduction. I collect all ideas I have during writing the text to this section. Because when you will start to write introduction from a clear sheet, then this is very difficult. You should have already some hints of what to write about. And then after strong interior struggle with yourself, you say, okay, today I write introduction. You try, and when you see that what happens is not satisfactory, this is not what you want, I strongly recommend to read introductions to other papers, which are written by English-speaking authors. This is quite important, or to some very high-level mathematicians who do it professionally, and try to project, try to translate their structure, their words in the introduction to your subject, to what is you going to say in your texts. Such a translation often lead to good result. I strongly recommend it. Also, you can take some language chunk. You can take some phrases. I don't recommend to copy paste because this will be some plagiat, but some phrases, ideas you can use. This is okay. Now, when you put a paper on archive, it's sometimes written that this paper, this is done by system. This paper has citation from another paper. The archive system inform you and all people, this is visible for all, that in your text, there are some parts taken from other. Certainly, maybe it's a bad sign if you take one paragraph, two paragraphs, but sometimes this is okay. And it's clear that in mathematical language, there are some intersection, you use some standard phrases. This is okay. Also, when you have some, at least first version of the introduction, please think how logic is it. Now I will go to my personal proposition, what should be in the introduction. But in any case, when you have your own version of the introduction, test for logic, how this phrase is connected with the next phrase. This should be first, this should be second. This follows from this. Please think about this and check. Okay. And it's also very important to demonstrate that you know the subject well and you cited all related earlier results in the introduction. I strongly recommend you because this is also the source of conflicts. Say, for example, you prove some theorem, A equal B. And this is your main theorem in your life. I don't know, you are very proud of this. This is your main achievement. And in 10 years, you read some paper about the subject that A equal B, and you are not mentioned. You cannot sleep. Because this is main achievement of my life. And this strange guy who wrote this paper, he even didn't mention me, my results. You ask colleague, what do you think? All colleagues say, okay, we agree with you. You are the author of this theorem, A equal B, this is your result. And this paper, okay, will have some troubles. There may be some, in good cases, there will be advice from the reviewer that you should mention this and that paper. And in bad case, you may get negative response, negative reaction. So. And this is indeed not honest, because this person, he was the first, and he deserved to be mentioned in the introduction. So, as we already discussed before, there are this mathematical publication database. There is Google. You can Google. Please remember this when you prepare introduction. And that you also some commenting words. Say, for some paper, you can write that this is, I don't know, pioneer paper. This is a seminal result, most important result in this field. And some result you just mentioned, or just, there are some results obtained in this paper and so on. This is also your choice, but you should think about this. Which result should be mentioned in which way? Okay, it's difficult to formalize it, but it's important to think about this. Okay, let us go to the next part. I took an example of some concrete paper. This paper, maybe we will use now not this slide, but the paper in its own. We need to demonstrate the screen. In fact, when I was preparing for this talk, there was some difficulties with example, because to illustrate something bad on concrete people, maybe this is a bad idea. But here I would like to illustrate something good. I was asked by the organizer to give example of good introduction, and maybe go up to see the title and the author of this paper. After some hesitation, I took this paper by Benjamin Neal. This is a German mathematician. Now he is quite experienced, but at that time, at 06, he was young. It was his second paper. And I like this paper very much because it's written by a young person, but it already has some good structure. And there are several ways to write introduction. Benjamin variant here is to like something like excursion. He takes us through known result. So he tells some stories, how it was proved earlier, what is known, what is not known. And he goes through, firstly, existing theorem. He mentioned theorem 1.1 by Matsushima, theorem 1.2 by Mabuchi. He gives some short comments, illustration to this. He goes further. Here again, some known result. And now we come to theorem 1.4. This is his own result. This is a result in this paper. But he somehow naturally included into the story. He said, okay, this was known, this is one, this is natural to conjecture, to ask about this. So we do this. This is what is done in this paper. So he includes naturally his own result to the text. At least this is very interesting to read. Such an excursion style, when me personally, when I read introductions, this is not too technical. You see almost no formulas, and paper is rather technical. But I enjoy it. When I go briefly through such type of introduction, I really learn a lot because there is a lot of information on concrete result, and this is easy to follow and to understand. Okay, let us go further. Again, some result by other people, by Van Ken Ju, and again, some result corollaries from his paper, from this paper. But after this interesting part, let us go further. Here are some precise formulation of the result of this paper, and with some notation. But notation and technical details in the introduction should be minimized. So you should think and try to reduce to the minimum the number of letters, specific symbols, and so on. The text should be as romantic as possible, okay? But after theorem 1.8, he stopped with this excursion part, and he come to the precise structure of the paper. In some sense, he repeat what is written about his result, but in another way. In section 1, this is done. In section 3, this is done. And in my opinion, this duplication in this case is also quite reasonable, okay? So here people understand precisely all formulation of the main result. And also I think that this is a duty of the author to formulate all main result in the introduction. If you cannot, you say, oh, no, my results are so technical, it will be pages of notations, please think more. If your results are really important and deep, there should be a formulation which don't require too many notations. This may be not precise formulation. This may be some rough, but principle formulation. What is really is this about? But all main results should be included into introduction. Okay, and next you go to this background, to notation and basic definition. Okay, I will not go through this paper, but we will return to this example also in next slide. Okay, let us return to our main part. And this is my recommendation. What should introduction includes? Maybe this is too much. And even I firstly wrote this list, and then I looked at a concrete example. And I saw that almost no introduction contains all of this. But at least major part of these points should be in the introduction. You begin with some story, background of research question, I don't know, some motivation. What do we study in completed general words, and why do we study this? Then you may come to previously known result. You can do in this excursion style, as we saw in the previous example. This can be done as a list of results. Maybe not so many theorems should be called theorem. Maybe there should be some texts where formulation are distributed between paragraphs. Okay, then you should use your main major results. Okay, this is completely necessary. Without this, introduction makes no sense. After major results, it's good, not necessary, but good, to explain your ideas, main ideas behind the proof, and maybe methods. Say, which technique do you apply? This is also useful for reader. Say, if it's written that, I don't know, we will prove this and that using technique of toric varieties, maybe if you are not interested in this result, but you are interested in toric variety, you can also read this paper. Because, okay, I'm looking for all possible applications of toric varieties. So, okay, I'm interested in this subject. Then about example and applications. It's good to include them in the introduction, but don't make introduction too long. It should be compatible with the size of your paper. Say, if this is a short note, then introduction should be 1 page, not longer. If this is, I don't know, 15 pages paper, then introduction of 1, 2, not 3, 2.5 pages is also okay. So if the size of your current introduction allows you to include examples and applications, please do it, illustrated by example. But again, remember that this is not a textbook and you should not include all examples and applications definitely in the introduction. This is a question of your taste, okay? And it's also possible to mention in the introduction your ideas for further research, open questions, problems, okay? This can be done in either in introduction, or at the end you can produce specific section called open questions, open problems, and so on. This should be something valuable, something important. This is not, say, I cannot prove such a technical lemma, and I put it as a question, please help me to prove this technical lemma. This is a strange idea. But if I see some principal question which I am unable to answer at the moment, it's good to put this in the introduction or in this specific section at the end. Say, I remember once I found a paper by some good mathematicians, and they solve the problem which I had in mind, and I was sure that I formulated this, and it was strange for me that they don't mention me. But then I looked at the papers which I wrote on this subject, and sorry, I forgot. I forgot to mention such an important question, and I see that it was my mistake. So no questions to this nice mathematician. They do it on their own, and this was my mistake that I didn't formulate explicitly this open question. So please think about this. Don't forget this. Okay. Okay, let us go to the next slide. And this is about keywords. Many people ignore this and think that this is quite elementary thing, so nothing to discuss. But I would propose to right to the chart. Here are 6 variants, and I need your opinion. Which keywords are good and which are bad? Okay, we have already quite many reactions, answers. Thank you very much. So maybe I will continue. And to comment on this, I will not say that now I come with a correct answer. Certainly, this is also up to you when you write your paper. But I will make my comments. What do I mean? In my opinion, good keywords are number 1 and number 4. Chebyshev polynomial and minimal surface. Because it really, say, when I read such a paper with such keywords, I understand from which area of mathematics is this paper, and very approximately what it can be about. This gives me some directions, idea. Topology, some people I saw that also some people say that topology is a good variant. For me, this is too general. Because yes, it gives me some information. This paper is about topology. The title may be, I don't know, not clear that this is about topology, but we specify in keywords that this is about topology. But in my opinion, this is too general, like mathematics. Okay, we believe that this is in mathematics, but this is too much. Number 3, I didn't see anybody who says that number 3 is good. No, yes, Vasily Gromov said that this is a bad variant. Okay, so this is clear, very strange keywords, 2 lemmas on integrability. Integrability, this is possible keyword, but not 2 lemmas. Number 5, okay, this is taken from really existing paper. And maybe some people know what these technical symbols mean. I just came to archive, I looked through some papers, took the symbol and put it. But for me, it says nothing. I'm sorry, I don't know what is this. This is from other area of mathematics. And me personally, it doesn't say, it doesn't help to specify what is the subject of this paper. But I am also some mathematician and say, I know what minimal surfaces are, what Chebyshev polynomials are, and these technical symbols, this I don't know. So at least for me, this is bad keyword. And number 6, okay, but this is a question of some taste. Some people help me and explain what this means. Okay, I'm sorry. Maybe this is very common for people from other area of mathematics. Say if I want to use keyword number 6, I should at least work on this. To make it shorter, to subdivide it into several keywords, to avoid this comma and so on. Because optimal variant for keywords, in my opinion, are 2 words. Chebyshev polynomial, minimal topology, minimal surface. 1 word like topology. This is, if it's not too general, also possible. But such a long phrase with comma, I'm sorry, I don't like it. Okay, but at least this is a reason to think about this more. Okay, let us go to the next slide.
Sorry.
Yes?
It's a really big question. Where do you suppose these keywords to be present? I mean, where do people read them?
This is usually used in as the first page. Almost all journals in their standard, they put keywords and American Mathematical Society subject classification. So you should put them with the usual requirement.
Yeah, that's for sure. But usually, well, so usually one gets to the published paper only after he knows that this paper is published and after someone has already read the preprint.
You mean
So,
the reason why people use these keywords? Are they needed or not? This is your question.
Well, it's more like, do I have to write these keywords if I only make a preprint?
In my opinion, yes. Because what is the reason to publish a preprint? It's the same as the paper, you want people to read it. And this helps to solve our main problem, to help the reader to understand what is it about. So say, paper is called something on manifolds. I like manifolds, this is question close to me. But when I read keywords, I see that this is from probability theory. Oh, sorry, this type of manifolds I will not understand. This is very far from me. I will not spend time reading this. Okay, so I'm grateful to the author that by keywords, he informed me that this is other type of manifolds, other story, and I stop reading at this point. This is my, again, personal opinion.
Yeah.
Okay, there is some discussion. I don't follow. About abstract. Where to put keywords, and there is a discussion, abstract, after abstract. This is done by standard system or journal style file or by LaTeX system. They propose this place. And I strongly don't recommend to make experience with this. Please follow standard tools. Usually this is on the first line at the bottom. This is specific line keywords downstairs. Okay, now about acknowledgements. Again, in my opinion, this is important. Maybe I ask you again in the chat your opinion about what do you usually write in acknowledgements. Let us compare. What do we think? There are already some comments. Grants, funding, institutions, colleagues. Okay, colleagues that helped. Supercomputer, very nice idea. I don't know how much does it concern pure mathematics, but it's a good idea to thank supercomputer in any case. So, okay, thank you for your comments. Maybe I will make some remarks on this. In my opinion, acknowledgement is very important, but it should be short and standard. Don't be too romantic, enthusiastic at this point. If it's a book, then okay, you can thank your family and I don't know who else. But if this is a paper, usually standard words are okay. And this should be not so long. Maybe continue. I remember that here should be some example of acknowledgement. Yes. This is again from this Benjamin Neal paper, which we already saw in Mathematical Zeitschrift. And this is rather long. And please remember, Benjamin was very young. This is his second paper. But he used some standard word. He thanked his supervisor. He thanked two colleagues, to grant, DFG. He mentioned that this work is a part of his thesis. For us, I don't know how common it is. I saw it quite rarely, but nevertheless, this is okay. Because, and one more point, you may thank to a colleague in general for advices and encouragement, and you may thank for example 3.24. Both variants, in my opinion, are okay. Concerning romantic acknowledgement, I remember I read it several years ago. It was some textbook, maybe graduate text in mathematics by Springer. And it was excellent acknowledgement. I will not say it in English because I'm afraid that I will make a mistake. It was written by American mathematician. But the acknowledgement was the following, translation in Russian. Я благодарен своей жене и детям, несмотря на все усилия которых эта книга была написана. So in my opinion, it was very good. But when this is not your language and when you write some specific notebook, but article, I don't recommend to make such jokes, but sometimes I enjoyed them very much. Also, it was a recommendation, I see it in the chat, to thank the referee, the reviewer. Yes, this is a good idea. But if you are really grateful to the referee who spent a lot of time reading your hard paper and make many suggestions which really improve the presentation, then in my opinion, this is your duty to send to this anonymous person. Nobody knows who is this. And also journals like it very much. When there are many acknowledgements of this type, it's clear that the authors are happy with the level of expertise of the reviewer. And this is a good sign for journals. Also, there is a typical mistake when people put their affiliation here, say acknowledgement. This work was done in this and that universities. I don't know whether Vice Rector Maria Yotkevich is still with us, but she, in any case, she will tell us that when we consider academic bonuses, such affiliation in the form of acknowledgements will be not taken into account. So affiliation should be where it should be. Usually this is at the end or at the beginning after the name of the authors. And acknowledgement it is not taken formally as an indication of your affiliation. Okay, all time runs quickly, so let us go further. Okay, now a reference list. This is a quite typical place for, I'm sorry, for conflicts with my students, because I don't understand what the difficulty is. I understand that it's difficult to write a good introduction. I understand that it's difficult to make a good structure of the text, that this is a source of conflicts with students, and it's difficult to write introduction, it's difficult to structure the text, but to produce standard leaf of reference, there is no difficulty at all. And I always see some problems with this. Okay, you should follow some standards which you produce by yourself, okay? If it's not decided to which journal you should go, this is up to you. But please make it in the same way for all items in your list. Say authors with names, after authors, dot, then the title of your paper from the capital letter, then again dot or comma, but in the same way with all publications mentioned in your list. So make it in the same style. You can make some difference between articles, I don't know, survey, conference publications, okay, up to you. But there should be some logic. And it's very bad when you put some, I don't know, names of the journal without abbreviation. Next item, this is abbreviated. Next item, no title of the journal at all. Look, editors from the journal you are going to publish this paper will not do it. This is quite rare that some people do some technical corrections. Or they will do it, but up to some level. They expect that you will make your list of reference by yourself in a good way. So please take care about this. And this is very, very easy and important. Next slide. This is a file which you received before our today's meeting. This is produced by American Mathematical Society. And this is a list of standard abbreviation of journals. So again, strong recommendation, follow this. I found this file with these abbreviations quite soon, and I'm very happy that now I have it. Because in High School of Economics, through the library, we have access, and we could go to math.scinet and look for each concrete journal, but this is much more convenient to use this list. And at some point, you maybe not agree. Say, in Russian, математический сборник. In English, сборник mathematics or сборник maths. And here they propose abbreviation SB. You can say, oh no, this is a bad idea. I know better how to abbreviate сборник. No, you should follow standard abbreviation. And in any case, after final publication, your variant will be corrected. So if this is a source for agreement, we should follow this. Okay, let us go to the next slide. And now you decide that the text is ready. I strongly recommend to read it several times with different aims for different purposes. Firstly, to read the text, don't pay any attention to logic, to correctness of proofs, to clarity of presentation, just mistakes and typos. Concentrate on each word, is it typed correctly? Are there no extra symbols and so on? Next, check all proofs locally. Say it's written, A implies B. Please check. Does it really proved here in this sentence that, or in this paragraph that A implies B? Don't pay attention to the whole structure, just check correctness locally. And then next reading. Now, no attention to these details. Look how logic, how clear is the text as a whole, okay? In my opinion, it works, okay? Because to do simultaneously correction of mistakes, misprints, and also to analyze the structure, almost impossible. So people ignore something, and this has bad result. And quality of your text, this is your responsibility. Because sometimes some editors received some texts which are very badly written with many misprints, bad English, I don't know, unlogical and so on. They will not say that they reject your paper just because of this bad presentation. They will find other reasons. Say results are not so original, say it doesn't correspond to quality of the journal and so on, and you will obtain this negative answer because the editor thinks that there's no chance to improve by their what they can help you. This is impossible to improve it. In fact, once I have a very nice example. My colleague, he received from very high level journal Invenciones a paper which contained very good result. It was very poorly written, and editor asked him, please help us to improve it. Just we ask you personally because we want very much to publish this paper, but in this form it cannot be published, and our correspondence with Arthur shows that it's no chance that he will improve by himself. So this is possible, but only for extraordinary result, only for best result. And don't expect that will happen with your paper. With big probability, there will be rejection for, I don't know, any other reason, but the quality of the text also taken into account. One more recommendation. Say, you did everything. You came through all the steps. You corrected all misprints. Everything is proof and logic. And you read it and say, oh no, it's not clear. This is badly written. From the beginning, I took bad idea with the structure and so on, so quality is poor. But I have no power. I am so exhausted. I don't want to make this terrible job from the beginning. Please do. Again, because in mathematics, I don't know how many papers do you produce per year. Usually people produce 1, 2, 3 at most, 4, 5. This is not usual. So please do. If you see that structure was bad, but the organization will require a lot of time, okay, no choice, you should organize, because clarity of presentation is a very, very important point. Okay, let us go to the next slide. And now I come to the question which I personally already answered, but I want to know your opinion. What do you do first? To decide to which journal you will submit your paper or to write a text? So majority is for the second option.
Yeah,
right?
exactly. And in the chat, I think everybody is for the second option. Yeah.
Okay, thank you very much. In my opinion, also, I would vote for the second option. And this one was once the reason why I decided to participate in this activity and to give this lecture, because in many other areas of science, there is a recommendation, I heard it many times in Higher School of Economics, please choose the journal first. Because journals have specific requirement, you should structure your paper in accordance with journal requirement and so on. In mathematics, this is very rarely happening. Almost all journals have standard usual requirements and no need to write a paper specifically for this journal. This is much more important to prepare a text, and only when the text is ready, you think about this and you decide which journal is suitable for your purposes. Okay, but again, this is my personal opinion. Okay, let us go to the next slide. And now we come to this choice of journal. Oh, this is a big fun. After this hard work, you have a funny stage. Extremely interesting when you discuss this with your co-authors and when you have some discussion which journal should we submit first, second, and so on. Firstly, a regular journal, special issues or conference proceedings. Sorry, I work at the Faculty of Computer Science and I know how conference proceedings are important in computer science. But in my opinion, this is not the case for pure mathematics. Say if you are invited as a speaker at International Mathematical Congress and European Mathematical Congress, this is big achievements. You are very proud of this and this is quite reasonable, but not because you publish in proceedings of this conference. You are a speaker of this proceedings. This is important at this conference, and proceedings are somehow something secondary. So again, my personal recommendation, I strongly recommend regular journals because they will be available in 50 years, in 100 years, and so on. Say sometimes I need to read, I don't know, Mathematischen Annalen from 19th century, and I can find this easily in the library. But this specific proceedings conference, they are not available in several years or in many years, I don't know. Certainly it also depends on proceedings, on issues, but general recommendation will be like this. Okay, next point, please. Again, this is up to you. But what I propose to make a list of 3 potential journals, especially when you work with co-authors. Say we submit for this journal first. If we have a rejection, then journal number 2. If rejection, then journal number 3. If 3 rejections, then we will think again, maybe rewrite the paper, I don't know, to change something more essential. And how to look for them? People don't like this bibliometric qualities, quartiles, and so on. But now it becomes more and more important, and also public opinion changes. I think that it's reasonable to use this. Higher School of Economics produce a list of journals. Publications in the journals can be supported by so-called academic bonuses. But for other branches of science, they have some other mechanism to produce these lists. But in mathematics, this is just based on Web of Science. Yes, we know that Web of Science has some specific, and you can give many, maybe non-clear examples when this journal is very popular, but it's not in the first quartile and vice versa. But up to such fluctuations, I would recommend to use this list. We will see this list in a moment. Do we have some more items on the slide? Yes. And you should be honest with yourself. You should ask yourself, what is the quality of your results? I don't recommend to send all publications to Annals of Mathematics. If you don't think that your result corresponds to this level, please don't do it. If you think that you prove something really crucial, then there are, I don't know, a list of 6 journals, which I like very much. I don't know, this is quite common opinion. Annals of Mathematics, Invenciones, Acta Mathematica, Duke Mathematical Journals, what else? Journal of American Mathematical Society, Journal of European Mathematical Society. This is the very top. If your results are more special, more, how to say, not so prominent, please use other journals and consult your colleagues. Maybe they will give you advice. And one more recommendation, also a journal specialized on size. If your paper is long, say extremely long, 100 papers, then there are quite restricted list of journals which theoretically publish paper of such a big volume. If your paper is very short, say, I don't know, 3-4 pages, this is also a problem to find journals which agree to publish such short paper. So just look for this. Say, London Mathematical Society, bulletin for short papers, journal for middle papers, proceedings for long papers. You should know this before submitting. Otherwise, you will waste time in non-necessary correspondence. And also, I strongly recommend you to look at journal's web page. People say, this is written, very standard words. We don't need to waste time to read this web pages. No, there are some useful advice. You should look for an editor. Usually the system asks you whom you want to be the editor of your paper. And this is some art to find such an editor. Some people, maybe I will skip specific comments, but this is quite important. Okay, let us go to next slide. And this is this list which I mentioned, which is produced in Higher School of Economics. This is based on first and second quartile in the Web of Science. But for me, this is a useful information when I say, I want to submit a paper, and I go through this list. ACM transaction on computational logic. No, sorry, I don't work with logic. This is not my subject. Acta Mathematica. No, I know that this is from top 6 and my paper doesn't correspond to this. Algebra and number theory. Maybe this is a good variant for me. And then I go to the web page and to look closer to this possible variant. So to go through such list, not necessarily from the beginning, you may go from the end, is a good variant to look for a reasonable journal. This table is also available for you. Okay, let us go to the next slide. Now several words about archive. Firstly, I think that there is no doubt that all papers should be sent to archive. Different people have different opinion, but in my opinion, this is completely standard mechanism, platform to distribute mathematical results. And people usually read papers on archive. And then you say, okay, and maybe we don't need journals, maybe just to put all papers on archive, why do we need this publication? In my opinion, journals is some sign of quality. People read my paper on archive, but people know that this is published in Duke Mathematical Journal. Okay, so it came through very strong reviewer process, and maybe this is a good paper. Okay. Why journals agree that people put papers on archive? Because maybe this is destroy their commercial plans. No, because for mathematical journals, the number of individual subscribers, I don't know, tends to zero, almost no one. Main money to journals come from subscription from libraries, and there is no competition with archive. So I never heard that some journals are against that you put your paper on archive first. Usually people put paper on archive at the same day as they do the first submission. Certainly there is no such a general rule, and some journal may think, aha, we got this paper and we see that on archive it was put, this was put, I don't know, 2 weeks ago, so it was submitted to some other journal, rejected, and then we received this journal today, this paper today. Maybe such reasoning is possible, but this is quite funny. And also, I recommend to use the same file for your submission in journal and on archive. There is no need to produce 2 different files. And this is quite strange to put on archive the style file of the concrete journal, because then you say, people, I submitted to this concrete journal, and maybe it will be rejected, and you will be in an, I don't know, unpleasant position. So it's better to use the same standard file for both submission, for archive and for journal. Okay, let us go to the next point. And this is what I said. So style file are present on many journal web page, but they don't insist on that you should use this style file for first submission. Usually it's okay if you submit standard file, then you have some report, and only after acceptance, they say, please retranslate your work into our style file. Okay. Some people start to do this before the first submission, and they spend a lot of time for this hard work. Me personally, I don't recommend. I don't do it.
Sorry?
Yes.
Doesn't it affect the reviewing procedure?
In my opinion, not. Say I got a paper for review, I don't know, from Annals of Mathematics, and this is not in the style of Annal Mathematics. For me, this is okay.
Thank you.
Well, the opposite variant is quite strange, because when I got this paper in the style file of Annals of Mathematics, I think that this author, they are sure that they will be published in Annals of Mathematics, and I am, as reviewer, is not so sure. So reaction may be opposite. But this is again some personal opinion. But if you don't like all the steps which I discussed today, this is a way to skip one step and to make it easier. Okay, please, next item. About using electronic submission system. Yes, we mathematicians, many of us have problems with some electronic system, we don't like it. And some people say, oh no, I will not do it. Please try. Again, invest some time and do it, because journals, this is much easier for them if you use electronic submission systems. But there are examples when something doesn't work. Say it's written, press this button. You press and everything falls down. I saw such a system. You write a message to this technical support. No answer for 1 week. What may be your reaction? I will submit to other journal. But if you want this journal, if you think that this is suitable for your paper, then I would recommend to submit via email to the editor. You can always find, again, on archive, or I don't know, on some web page, the email of the editor, and send to the editor your submission. Okay, next Also, some delicate tips on paper processing. Again, two extremes. Either you send your paper and in 3 days you write a message, oh, is it ready or not? Is it accepted or not? Certainly, this is unpolite. Consideration of mathematical paper definitely requires some time, and this time maybe, I don't know, something. But also, all we are alive people, and we can do mistakes, something may be lost. And you say, in my practice, I had it, the journal can forget about your submission. And in some point, it's a good idea to write a paper and ask how it is with my paper. What is a term? In how many months, I don't know, you should send such a recall. In earlier time, I would recommend in a year. Now, time running quicker, and maybe now it's possible to write it in a half a year, but not earlier. And this letters should be very polite. Please try to formulate it as delicate as possible, your question. Because editors, reviewers, these are persons who work hard for your paper, and you should be grateful for this. So some delicate message is possible. Okay, please, next slide. Now, some information which is relatively new about procedure. Now, mathematical journal, they are not computer science journals, they are not so quick, but they are thinking how to speed up this process. And one decision is so-called quick opinion. Say, the editor received your submission, and he sent it to several specialists in this area just for short opinion, just for quick opinion. They don't ask for a complete report. They just ask you, is it reasonable to consider this paper for publication in Annals of Mathematics, say, or in, I don't know, in Acta Mathematica? If the answer is no, then they answer the author that, sorry, maybe your paper is good, but you should send it to more specific journal. For our journal, it doesn't meet the standard of our journal. Okay. And again, this is not so bad for you. Certainly, it's non-pleasant to get negative answer, but if it is given in such a short time, then, okay, this is also a possible variant. Me personally, when I submit a paper to a good journal, I wait 2 weeks. And if there is no negative answer in 2 weeks, I say, phew, maybe quick opinion were positive, or maybe there were no quick opinion, but I don't know. No quick rejection. And then I wait for complete report with all comments and so on. Okay, now concerning communication with the editor. My first, again, very personal advice is not to try to identify the editor, because this is a source of very personal negative emotions. Say, aha, I see, this is a specific phrase, and this is used by this guy, I remember him from this conference, so this is definitely written by him. I will never forgive this answer. Sometimes they are not polite. In my life, I got such reports that I was unable to sleep after this, I remember this. But it's, in my opinion, this is a bad idea to make prediction, or I don't know, expectation, who is this person who wrote this very unpleasant report. This is non-productive. Also, I strongly recommend when you answer to reviewers to make not only corrections in your text, but also specific file, which when you put list of all corrections and you respond to all reviewers' comments. And I strongly recommend you to follow the axiom, the reviewer is always right. Certainly you will disagree with me, because reviewers, they can make mathematical mistakes. They say that this lemma is wrong, and this is a counterexample. And you see that this counterexample doesn't work and the lemma is right. But you should find some delicate words to explain that, okay, so this is obviously not. But you should try to take as much reviewers' comments into account as possible. So this list of correction, I don't know, there are 20 items. And 18 of them should be just done, 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 done. So you did what the reviewer proposed to you. And maybe in this list of 20 comments, 2, maybe some discussion with the reviewer. that, oh, I propose to do this and that, so I follow your advices, but I do this in this and that way. This is okay. Sometimes you can address to the editor and say, I disagree with the reviewer. But this is non-productive also. This is almost never work. Because this editor, he asks the reviewer, he respects this reviewer, he considers him as a specialist, and he relies on his opinion. So also this is necessary to think about this. Okay, and also I know how difficult the reviewer work is. If you publish your paper, certainly you usually don't get any money for this, but this is your result and your name is written at the title and so on. But when you are the reviewer, you work on this paper, I don't know, hours, weeks, months, and your name is unknown. So you do this work, and what you get is just angry answer from the author. I don't agree, this is strange, this is wrong, and so on. Oh, this is very unpleasant. I have the list of some authors, and if I get a paper by this author, I just send to the editor, sorry, I will not do it, because I already have this experience with this strange discussion with this author, and I don't have time to do it once more. So please be delicate with the reviewer and follow the deadline. Yes, sometimes you can be, I don't know, say you are waiting for the answer from the journal, I don't know, for a year. And then you received a paper from the journals, please do this correction during 1 week. You say, oh no, the situation is not symmetric. I was waiting for their answer for 1 year and then want me to do all corrections in 1 week. This is very rarely happen. Usually journals propose reasonable time. But sometimes if say this is not first report, but second, third report, they can speed up, you say, please do it quickly. I strongly recommend you to do it quickly. And also at the final stage, when your paper is accepted, all corrections are done, and you obtain for proofreading the very final file. And some technical guy from this technical support asks you to check some misprints, some, I don't know, some maybe wrong symbols. And you say, I see a better proof of lemma too. And I want to change it in this final file. No, journals don't like it. This is also maybe a source for rejection. If the text is agreed by you, then also small corrections, small misprints, but no essential reorganization of the text at this final stage of proofreading. Okay, so if you have some questions, some answers, they are also very welcome. Please let us do it. You can use, I don't know, your voice chat, what you like.
May I have one?
So,
in principle, today you have described in a beautiful manner the situation of the group working locally. So you get some answers by the blackboard, you get your theorems, you get the results done, and then you can write them all down. But if your co-author is somehow in Japan, so then speaking to him over internet, you have to type something already and you have to send him part of the text. So therefore, at some point when you understand that you get the result, that means you have already lots of texts. So there is a big question, how to produce it efficiently. So how to write down these small texts and how to do this conversation so that finally you get not many small pieces, but one good text.
Okay, thank you. Very good question. But in fact, my experience is not only about local groups. Say I mentioned our paper with 5 authors, and authors are our central authors. One was in Grenoble, France, then in Bochum, Germany, then in Bern, Switzerland, in Miami, US, and me from Moscow. Yes, and we met later, but when we started to work, even not we not saw each other. So somebody were acquainted and some were unknown to each other. But it was some communication. We decided that I can try to prove this, I can try to prove this. It was some general idea, general scheme which we should follow. And we sent our pieces to this central authors and to discuss with him. Yes, this is a terrible work, exhausting. But if you want to work together, there are some technical tools, but In this team, I was the youngest guy, and we don't use some specific tools, just sending via emails some texts and discussing them, correcting them in email correspondence. So it's possible. I can show it by our example. But yes, some people, they say, certainly, there is a very deep observation, I like it very much, that email doesn't send emotions. Then why guy say something, in his opinion, neutral. I propose to this, this, and this. But it's maybe written in such a way that other co-authors maybe consider this as something very emotional, and then can be angry with this. And some conflicts and so on. It can happen. And people say, okay, after this bad experience, I will never work together. It's much simpler for me to make papers alone. But please believe me, this is a bad idea. Please be silent, stop some, I don't know, emotional discussion, continue to work and try. It needs some force, but try to work together. And the results will be much more visible in this case. Okay, but where an article has more chances to be published in the proceeding of a conference of computer science or in a journal, the paper is on data analysis. Sorry, I will not make recommendations on data analysis. Today we speak about pure mathematics, and my experience is only in the area of pure mathematics. I see here at the Faculty of Computer Science many colleagues who publish paper on the level A star, but it's better to consult them. You may organize another meeting on this subject. Because I speak with them, the ideas, I don't know, approaches, everything is completely different from pure mathematics. So my experience is not applicable here. Okay, any more questions, comments?
How do you think whether it is reasonable to merge introduction and literature review, or on contrary, to separate them?
Vasily, please tell again.
Whether it is reasonable to merge introduction and literature review on the same bulk of texts, or to separate them?
I don't insist that there should be a complete literature review in the introduction. There should be a list of reference. This is usually at the end, and you can refer. Again, by definition, there should be no items in the reference list that are not mentioned in the text. Journals usually control this, and this is quite clear. But you can mention this paper in the either in introduction or in the text. This is up to you. To make a specific section on the literature review, no, this is, in my opinion, strange for research paper. But to decide, would you mention this in the introduction or somewhere in the text, this is your choice. Even if you prepare a book, some really brave people make a section, I don't know, historical overview, who prove what in this area. This can be done only by very brave people, because after this, they have millions of enemies. Say, recent paper, toric variety by Cox and Schenk, and I don't remember all their names. And they, yes, right. And they have a section about toric varieties, who proved what first. But they did it very carefully. They studied a lot of literature and then justified all their opinion. But please think, are you brave enough to do it? Definitely not in the research paper, but in the book. Okay.
Yeah, I have a question. May I?
Yes, yes, sure. Let's continue.
Yeah. Well, my question really maybe more concerns like computer science, but I think in pure mathematics it also may be the case. Well, does it make sense to upload the preprint to archive, say, or to ResearchGate? It was proposed. If the review procedure in the journal or in the conference is blind or double blind. Do you have an opinion on this?
Again, my recommendation was to put your paper on archive at the same day as you submit it to the journal. Maybe for computer science, for this conference business, the rules are different. So no recommendation from my side. But I think that it makes you nothing bad and a lot of good if you put it on archive at the same time as you submit it. Concerning ResearchGate, I'm sorry, but almost no time to use the system. I think that many people use it, and this is quite useful. And I cannot say you that I recommend you to do this, because this is my plan for nearest months, is to study how it works and to come to this ResearchGate and to be there. But at the moment, sorry, no experience. I registered it, so there is my name there, but I don't use it actively. This is my mistake, I will do it. And this is some quite usual recommendation, how to study mathematical English, because mathematical English, this is quite specific language. You don't need to know usual English. It's not necessary to read newspapers to understand mathematical English terminology. So the collection of words is quite different. And there are some excellent books written by Alexei Sasinsky. The first one, How to Write a Mathematical Paper in English. This is from my, I would not say childhood, but from my very young years. I use it a lot. And there is some axiomatic approach to articles. Some people disagree with Alexei Branislavich's opinion, but in any case, this is a good source to think about this and to understand what the problem are. It contains a list of recommended phrases which can be used in mathematical text standardly. But there is also one more book by Semyon Kutatiladze. This is not so known in Moscow. This book is Novosibirsk, but it can be found in the internet, and I also would recommend to read it. There are also many useful and reasonable advices here. Also, some people are nervous that, okay, my English is so poor, I will not publish papers in English. But you have no chance. Almost all publications now are in English. Even if you submit some paper to our excellent journal, like Математический сборник, Известия, Russian Mathematical Service, Успехи математических наук, there will be a translation. And certainly it may be done not by you, but by professional translator. But even the best translators, they cannot understand on details. And their translation usually includes some mistakes because they are not mathematicians in your narrow area. So this is much better when you study this basic mathematical English and do translation by yourself. Or usually you don't do translation, you just write your paper in English. And some mistakes, yes, they are possible. I just would like to share with you some opinion from my personal experience. I worked in France with a colleague, and he said me that Russians, you are unable to understand articles. Because in English, in German, in French, they have articles, and we don't. And articles, they have serious meaning. Mathematical notions with articles say a vector and the vector may change the meaning of the phrase dramatically. And something basic, certainly we understand. Say, this is something non-determined, and the means something concrete, determined. But in concrete situation, I have a favorite example. I wanted to translate the following phrase. Для удобства читателя мы напомним в первой главе основные понятия. Я написал, and I wrote for convenience of a reader, because I was sure. Convenience, okay, there are some rules that there should be no article. But I don't speak with some concrete reader. I don't write it to concrete person. This is some abstract, unknown reader. So I wrote for convenience of a reader. And my colleague said, stop, I will not correct your text because you Russians, you don't understand very simple thing. It should be for convenience of the reader. And gave me some explanation about this and so on. And after this, I also was close to give up. So yes, we cannot. But it's clear that we will do some mistakes. And all people understand this. And this is not a reason to stop to write in English. We should practice with mistake. Okay, if there are some more comments, please.
Excuse me. And could you recommend any lower level source, say a short video explaining how to state a theorem, how to give a definition, and all that basic stuff?
Sorry, I'm not ready to do this. I'm sure that they exist, and I even saw it sometimes from American mathematicians, very reasonable text and video where they do such recommendation. But I don't have it at the moment. we should search it in the internet. Yes, it's a good idea to recommend, but sorry, not prepared. Okay. If there are no more comments, thank you very much for being with us and for your participation. I'm sorry if some of my recommendations are not well structured and not useful, but I really try to do my best. Thank you very much.